Okay, so here's our second example for Newton's second law. We have a 2-kilogram cookie tin is accelerated at 3 meters per second squared in the direction shown by A over a frictionless horizontal surface. The acceleration is caused by 3 horizontal forces, only 2 of which are shown, F1 with a magnitude of 10 newtons and F2 with a magnitude of 20 newtons. What is the third force, F3, in unit vector notation and magnitude angle notation? So we have 3 forces that are causing an acceleration. And we can see that we have 2 dimensions here. So we need to split all of them up into x and y components. So let's do that. Let's put the acceleration up first. So we have acceleration vector is up and at an angle of 50 degrees, and they give us that the acceleration is 3 meters per second squared. So we have acceleration in the x direction is going to be equal to 3 times the cosine of 50. And acceleration in the y direction is going to be equal to 3 times the sine of 50. So 3 times the cosine of 50 is equal to 1.93 meters per second squared. And then 3 times the sine of 50 is equal to about 2.30 meters per second squared. Okay, so there's our acceleration split up into x and y components. Now, since we've done that, let's do force 1. So force 1 is down at that angle of 30 degrees. So I'm going to draw it down here. We have this angle right here is 30 degrees, and our force 1 was 10 newtons. So that's 10 newtons here. So, and that's 30 degrees, kind of a dumb 30 that I just drew. So this will be our F1x and F1y. Notice how these are both directed in the negative direction. Okay, so I'm gonna have to put some negatives on there when I solve for these. So I get F1x is going to be equal to 10 times the cosine of 30. And then F1y will be equal to 10 times the sine of 30. So we get 10 times cosine of 30 is 8.66 newtons. And again, because that's negative, I either want to put a negative in front of that, or I just want to make a note that this is a negative number, okay, because it's pointed in the negative direction. And then 10 times the sine of 30 is, of course, 5. So 5 newtons, again, that's downward, so we know that this is also a negative number, okay? However you want to denote that, I just like to make a note on the side, or else I might forget in the future, which we don't want to do. And then F2 is pretty easy because it's directed straight up. So that tells us that the force 2 in the y direction is whatever the magnitude of that force is, 20 newtons. And then the force 2 in the x direction is 0 because there's no x component of that force 2. All right, so now we want to find out what force 3 is. So in order to do that, we need to use our Newton's second law equation in both the x and the y direction. So let's do x first, and let's do it in a different color. So we have the net force is equal to mass times acceleration. The net force is going to be made up of force 1 plus force 2 plus force 3. And remember, this is in the x direction. So we're doing x first here. So we get mass times acceleration in the x direction because our acceleration is both in the x direction and in the y direction. It's a 2-dimensional acceleration here. So force 1 in the x direction was a negative 8.66. Plus force 2 in the x direction was 0. Plus force 3 in the x direction, which is what we're solving for, so I'm leaving it force 3, and then equals the mass of the object, which they give us is 2 kilograms, times the acceleration in the x direction, which was 1.93 meters per second squared. So doing our math, we get 2 times 1.93. And then I'm going to add 8.66 to both sides because it's negative on the left-hand side. So this number, I have 3.86 plus 8.66. And we get that force 3 in the x direction is equal to 12.52 newtons. Now we have to do the same thing for the y direction. So net force in the y direction is equal to mass times acceleration in the y direction. So that will be force 1 in the y direction plus force 2 in the y direction plus force 3 in the y direction equals mass times acceleration in the y direction. Force 1 in the y direction was -5 newtons. Plus force 2 in the y direction was 20 newtons. Plus force 3 in the y direction, which is what we're solving for, equals the mass of the tin, which was 2 kilograms, times the acceleration in the y direction, which is 2.3 meters per second squared. So we end up getting -5 plus 20, which is 15 newtons, plus force 3 in the y direction equals 2 times 2.3, which is 4.6. Yeah. 0.6, and that's newtons. And then we're going to subtract 15 from both sides, so 4.6 minus 15. And we get that force 3 in the y direction is equal to -10.4 newtons. So in order to show this in unit vector notation, we have force 3 is equal to the y component, which was, sorry, the x component, which was 12.52 newtons, and then I hat, because that is our x, minus 10.4 newtons j hat. So that is our unit vector notation. And then for magnitude angle, we actually want to draw our triangle. So we have a positive x, and then a negative y. So our positive x was 12.52 newtons. Negative y was 10.4 newtons. And then here is our magnitude of force 3. So using Pythagorean theorem, we get square root 12.52 squared plus 10.4 squared. And we get 16.3 newtons. So that's our force. And then our angle will be the inverse tangent of 10.4 divided by 12.52, which is 39.7 degrees.